Okay, lesson of 4.2 is all about the straight line motion or the rectilinear motion. And here is where we connect position, velocity, and acceleration. We will revisit the idea that was introduced to you during topic 3.6. So when we study motion initially in calculus, we consider what is referred to as a straight line motion or rectilinear motion. When we study this idea, we are concerned with four concepts: position, velocity, speed, and acceleration. Now take note that this motion means that the particle or the object is moving along an axis. It's not moving along the graph of the function. Now this table is what you need to remember, okay? So position is denoted by S of t or X of t if it's moving along the x-axis, or Y of t. It tells us where the particle is located at a given time t. And then you have the average velocity. It's the average rate of change over A and B, okay, where t is between A and B. So the average velocity is simply the slope of the secant line. All right. Instantaneous velocity, on the other hand, is the rate of change of the position at a given time and direction of movement. So instantaneous velocity is the derivative of the position, which we know is equal to the value of the velocity at time t. Now speed, to differentiate it from velocity, the speed is the rate at which position is changing. So velocity is a vector quantity in that it has magnitude and direction. Speed is simply the magnitude, so it's always positive. The speed is simply the average, the absolute value of the velocity. Now acceleration is the second derivative of the position function, or the first derivative of the velocity. That's your acceleration. It tells us how fast the velocity is changing at a given time. So velocity is how fast the position is changing. Acceleration is how fast the velocity is changing. Now, what about displacement? So we're given two intervals, A and B. A is the beginning point and B is the ending point, the starting time and the ending time or stopping time. So the displacement over this interval is simply the difference in the distance from the starting point to the stopping point. And the distance traveled is equal to the sum of the absolute values of the distances between turning points. Okay, so we get the distance traveled from one point to another point. If it's positive, if you get a positive, that's it. That's the absolute value of positive is positive. If you get a negative, the absolute value of negative is positive. So once you have all those distances, taking the absolute value of negative distances and you add them up, that is the total distance traveled. Okay, let's take a look at some examples. So let's take a look at this problem on position. Example 1. So we are given the position function S of t equals t squared minus 2t minus 3. Show its position on the number line for t values of 0, 1, 2, 3, and 4. Okay, for the most part here, we will be using a graphing calculator. So let me just clear this out. Let's do second. You always want to clear your calculator. Second plus 7, 1, 2 to reset it. Okay, so let's go to y equals and let us store our function. So we're putting this function in y sub 1. And instead of t, we have to use x. So x squared minus 2x minus 3. Okay? So we store that on y1. And let's get out of that. And then we will evaluate this function value at t equals 0, 1, 2, 3, and 4. Okay. So you can go to vars, yvars, function y1, and then we'll plug in 0. And that's the value. Okay. And then you just do second enter. And then you can change that into 1. Second enter. And then you can change that into 2. Second enter, you can change that into 3. And then second enter, and you can change that into 4. Okay, so these are the position values at each of these functions. Okay, I can see the top now. Let's see. So y sub 0 is -3. Okay, actually you can do that manually right here, but just so you know that if the function is a more complex function, then you can put it in y sub 1. Okay, so we have at t equals 0. Let's see. Let me take it again. Okay, so at t equals 0, let's do the table here. Oops, sorry. Let me get that straight line. That's better. So if t, and then you have your s of t. So if t is equal to 0, your position is at -3. T is equal to 1, it's at -4. If t is equal to 2, it's at -3. At t is equal to 3, you have 0, and at t equals 4, we have 5. So let's plot this on the number line. So at t equals 0, this is your t function. At t equals 0, this is your x-axis, your position, okay? So when t is equal to 0, your s of t is at -3. So that's the starting position, okay? This is at t equals 0. And then at t equals 1, your s is at -4. So right here at t equals 1. So the particle is moving to the left. And then at t equals 2, you go back to -3, okay? So it went left and then it went right again. And then at t equals 3, you have it at 0. So t at 3. And then at t equals 4, the position is at 5, okay? Now, if you want to find the displacement for this one is the distance displacement. It's the distance between the final position and the initial position. So your final position is at 5. Your initial position is at -3. Okay, so you have 5 minus -3, that is equal to 8. So that means that's the distance between this point to that point. That's 8 units. And the distance, the distance traveled would be the absolute value. So from 0 to 1, let's see, from 0 to 1, that is equal to 1 unit, right? Because it's absolute value. And then from 1 to 2, 1 to 2 is another 1 unit. Let me add it down here. And then from 2 to 3, that is equal to 3 units. And then from 3 to 4, that is equal to 5 units. So the total distance traveled is equal to 10 units. So displacement, that's the difference between displacement and distance.